My dear friends, we are parallelly talking on engineering, procurement and construction commissioning of 66 by 11 kV substation, and at the same time we are talking on transmission line protection by overcurrent and earth fault relays also. So right now I am talking about engineering, procurement and construction commissioning of 66 by 11 kV substation. We have taken 2 sessions in which actually in first session we have seen what are the activities to be performed. No doubt the details of these activities we will be seeing. Details of these activities we will be seeing. But just for the sake of listing, we have listed in the first session. But all the same, it was very important to know about the busbar arrangement. Because as I told to you, 6.6 kV, 11 kV and 66 kV single busbar arrangement is used. For 132 kV, people use double busbar arrangement. For 220 kV also, double busbar arrangement. 400 kV and 765 kV, we are using 1.5 bus arrangement. So when we are using these arrangements, we must know what these arrangements are and how these arrangements are working. So that also we have seen in second session. So in third session now, we are going to start real engineering of the substation. So friends, as I told to you, how to plan and design 11 kV feeders, where to rather locate the pole mounted transformer or distribution transformer in an area. I mean, that is also a very important thing. Location of a transformer so that the losses, the distribution losses are the least. And then how to construct and lay out the 415-volt distributors is also subject by itself, but we are not touching that as of now. So we start with the understanding that we have predicted the load, and on 66 by 11 kV substation, the 11 kV feeders will go out. So we are assuming, or rather we have predicted that 3 numbers of 11 kV feeders of 1.5 megawatt each, 4 numbers of 2 megawatt each, 4 numbers of 1 megawatt each, and 5 numbers of 1.75 megawatt each. All 11 kV feeders are going in different areas. And for this, we have to rather engineer a 66 by 11 kV substation. And we also assume that we have 266 kV incomers for this. That also we assume. You can assume 3 also, and you can assume 1 also. But the disadvantage in 1 is that if one incomer fails, if there is a fault on one incomer, then the complete substation is gone. I mean, no consumer is getting power. If you go for 3, then it will be costlier. So we go for 2 incomers of 66 kV and so many outgoing feeders. So for this, we have to plan 66 by 11 kV substation. So if we go further, and if I assume power factor 0.8, which is quite realistic, and if you calculate the total load based on the details given, the total load comes out to 31.5625 MVA. So your substation should have this capacity, right? And obviously you have to understand that for the whole day, the load is not going to be same. That's what we have assumed. 1 megawatt or 1.75 megawatt is not going to be there. That load is the maximum load in the load curve. And your substation has to cater for that maximum load. So this 31.56, 2.25 MVA is the capacity of the substation. Maximum, so much of load will be there. Now it is quite possible that you can reduce this from 31.56 to 5, because there can be some diversity also, you see. Everybody is not using that maximum demand at the same time. I am using at 4 o'clock and you are using at 5 o'clock. But then right now we don't talk about diversity factor, because diversity factor is also a term by itself, and diversity can be arranged, or diversity can be made in many different ways. One way is forced diversity. Forced diversity means, I'm talking of Gujarat, then one district or two or three districts are not getting power on Monday, other districts are not getting power on Tuesday, so they are not receiving power. That does not mean that they are not receiving the lighting power, domestic power, because electricity board is not much interested in domestic power. This total load 31 MVA that I am telling, hardly 5% is domestic power. So we do feed domestic power, but then what do? Instead of feeding RYB, they feed RYR. They disconnect B and connect that B to R. So the lights will be on, fans will run, but three-phase motor cannot run. So main load, that is industrial load, that caters for industries, that will not be available for that district. That is a forced diversity. Government is by force not giving load to them. So thereby you can reduce the load. That means the maximum demand, which we have calculated here, but the actual maximum demand will be less by this divided by 1.3 or 1.2 or 1.4, whatever is the diversity factor. Another way the diversity factor is, you tell consumers that if you use electricity at night, because at night people usually are not using electricity. So if I say to consumers that if you use electricity at night, I will give you power at half the tariff or 3/4 of the tariff. I will charge you less. Particularly, you see, the municipal authorities are lifting water to overhead tanks, so that they can do at night. You see, it's not necessary to do at day. So that way also diversity can be arrived at. But right now we are not talking about diversity also. We take it for granted that 31 MVA is our maximum capacity. Average will be different. Average is 20, considering load factor of 65%, which is realistic. So average is less, but you will have to decide the transformer capacity based on 31.5625 MVA. So that is there. So now you will not decide 31, because you see today your load is 31, but electricity demand is increasing day by day. Say, if you want to know, as I've told you so often, that when Gujarat and Bombay states were together, they were separated on 1st May 1960. On that day, Gujarat installed capacity was 250 MVA. In Dwaran Thermal Power Station, there were only 4 generators of 62.5 MVA each, British made. But now you see, the installed capacity is more than 25,000 MVA. So electricity is day by day increased. So more and more electricity is wanted. And that depends upon the area. Say if you go to Kutch or Saurashtra where the development is less, there the electricity expansion will be slow. But if you go to Ahmedabad or if you go to Delhi or if you go to any main city, there the electricity is increasing very fast. So you have to consider some expansion also. So here I have assumed 1.3. 30% more load will develop after 2, 3 or 5 years. So I have to plant today because you see, on that day nobody will give me extra land nearby my substation. It's not possible. I have to buy today itself. So if I consider 1.3, my substation capacity comes to 41.03 MVA. Now 41 is not standard. There are certain standard ratings of a power transformer. So 45 MVA or 50 MVA is standard. So to say, I may have single transformer of 50 MVA, then I'll be able to cater. But then the problem is, if that there is a fault in that 50 MVA transformer, I'm losing complete load on the substation. No consumer is being fed. You see, there will be loss of production to on the side of consumers, and there will be loss of, so to say, the uh, loss of electricity, uh, loss of revenue to electricity company. So I don't do that. I can have two transformers of 25 MVA each, or one of 25 MVA and another of 20 MVA. That is also possible. So if one transformer goes, another is available. But then I have available only 25 MVA or 20 MVA. My demand at least as on today is 31.5 MVA. So I am not catering to the whole demand. So right now I mean that is a question of person's discrimination. It is a discriminatory factor, but I go for three transformers, two of 25 MVA, sorry, one of 25 MVA, I am going for three transformers. How do I go for three transformers? Uh, I go for three transformers. I'll tell you like this. I'm going for three transformers like this. That three transformers of 15 MVA. So 45 MVA is complete. My demand is met with. So you see what is really happening, that if there is a fault in one transformer, 15 MVA is gone and I'm left with 30 MVA. Today's demand itself is 31 MVA. So more or less I'm meeting today's demand if one transformer fails. So to say it is 100% flexibility. So this decision gives me that advantage. So I am going for 315 MVA transformer each. But try to understand that had I purchased 150 MVA, it would have been cheaper. 315 MVA transformers are costlier than 150 MVA transformer. That is for sure. That does happen. Not only that, but 315 MVA transformer will rather have a space of 3 times one transformer. So I will need more space. So I will have to uh, uh, go for more land acquisition. Then land is also costly. So you might be knowing that in Ahmedabad, what is the land cost. So this is what I decide for 100% flexibility. And then I will have to have either 266 kV PT or I can feed PT in a different way, that we will see. So this is what I am preparing, just a very rough single line diagram. Very rough single line diagram to know what I will be doing. I'm not showing all equipment. But what I am doing, B1 and B2, two breakers, two incomers, IC1 and IC2. And then there are only 6 or 7 outgoing feeders are shown, but all total outgoing feeders as we have listed will be going from 11 kV bus. Between 66 kV, this is a single line diagram, try to understand. Between 66 and 11 kV substation, there will be transformers. Incomers are outgoing, that is, they are on outside. The 66 kV bus is also outside, right? 3 transformer also in the outdoor area. So they are exposed to heat, they are exposed to cold season, and they are exposed to rain also. That you have to remember, right? From 11 kV onwards, it is indoor. So 11 kV switch gears are indoor. That I know from this. And how I am making a PT arrangement? I have 2 isolators because PT takes only few milliamperes of current, so breaker is not required. So I have 2 isolators, I1 and I2. So I1 feeds left half and I2 feeds right half. If there is a fault on left half, I will open out I1 and close I2. So I'll be able to have PT on both sides. PT is going to feed the voltage coil of energy meter, voltage coil of watt meter, voltage coil of VAR meter, and under voltage relay, if at all there is, right? And CTs which are not shown will be feeding meters and current coil of watt meter, current coil of energy meter, etc. So I have shown 3 transformers, and then between transformers and the indoor switchgear, there is a road of 10-meter width. Because when I am erecting the equipment, isolators will come, PT will come, transformers will come by truck or something. So those are to be brought inside the substation. So I need a road. So I have a road 10-meter width, about 30 feet width, quite enough, right? And then there is the incoming switch gear. So this is roughly my design. And what is the meaning of IC1, IC2, B1, B5, I1? That is also written on the right side. You can pause the video and you can see anytime. Then now I am showing you all equipments and I call it a bay. Says 66 kV side. When the incomer comes, first will be lightning arrestor. Lightning arrestor is a chokidar. Yes, it will be the first thing, because whenever any lightning stroke or switching surge, high frequency over voltage comes, that will damage the equipment. So that is grounded, and for grounding, lightning arrestor is required. Then there will be earthing switch. Then there will be isolator, breaker, isolator. We have already discussed that on both sides of breaker we need isolator, because when we are maintaining a breaker, it has to be completely evacuated. Then there is CT. CT from the top shows a circle, right? Because after all, CT is also a CT, PT, everything are brown and they look like the insulators only. But from where they are located, you have to know that this is CT. And you have to read the nameplate particulars also. You will be able to know which is CT, which is PT, which is the post insulator for bus bar, etc. You will come to know from that. So CT, and then there is a bus. Bus means not one, there will be 3 buses, RYB, and this lines also 3 lines, RYB. This is single line diagram I am showing. So this is known as bay, BAY, bay. And for 66 kV, the standard dimensions are 18 meter by 8 meter. For one bay, 8-meter width and 18-meter length between 2 phases R and Y. horizontal arrangement RYB between R and Y roughly 0.8, 783 exactly, 783 mm of spacing. That is 0.8 meter is required. But I am going for 1.5 meter. Enough safety. So 1.5 meter between R and Y, between Y and B 1.5 meters. So that makes 3 meter and complete is 8 meter. So in between 3 meter. So 8 minus 3, 5. So yet 2.5 meter both sides are left and then the next bay will come. Then the next bay will come. If you want to know the dimensions for 132 kV bus, it is 11 meter by 42 meter. Yet single bus arrangement. But for 220 kV, we will be using double bus arrangement and the width is 14.5 meter and the length is 75 meter because as the voltage increases, the distance between R and Y and B will go on increasing. So if you go for bigger substation, higher voltage substation, you will need more land. But right now we are talking about 66 by 11 kV substation, so we adhere to that. And for that, figure 3 is this. Now, this gives me the complete requirement of land. See, you can see number 1 is a bay because it is 66 kV. It is a PT bay, power potential transformer. 2 is incomer. Everything is written on left side, you can see. Number 3 is transformer 1 bay. So between incomer and transformer, there will be bus. Number 4 is sectionalizing breaker. Right. Number 5 is incomer 2. Number 6 is transformer 2. Number 7 is transformer 3. Number 19, I have kept spare for incomer 3. Right now I am only 2 incomers. But if load increases, I have planned for third incomer also. Number 8 is bus PT isolator bay because bus PT isolator is there. Number 9, I have number 8 is number 9 is spare bay for transformer 4. So if I need transformer 4 to be installed, I have kept the possibility of that. Right? That is number 9. That is fourth transformer. I am planning. Right now I will be keeping it open. I will not be putting because I will be putting only 3 transformers. Then around all these I am keeping 2 meters of distance. So if you say so, what happens is 8 meter width. So 1, 2, 3, 4, 5, 6, 7. 7 into 8 is 56 plus 2 meter on both sides. 60 meter of width I need. And what is the length I need? 18 meter plus 18 meter. So 36 meter and 2 meter I leave. Extra 2 meter I leave. Then there is 10 meter width wide road, right? Then 11, 12, 13, 14, 15, 16 all are incoming side. Indoor side. 11 is staff quarters because there will be an in-charge engineer. He will be there for 24 hours. He will be doing duty for 8 hours. But if some emergency comes, he will be there. So, or there may be 3 engineers in charge, junior engineer or deputy engineer. So 3 quarters may be required. And the line staff is also there. Some line staff are living in city, but some line staff would like quarters. So 11, that is 15 meter wide. 15 meter is quite wide. 45 or 50 feet, quite good length. And 10 meter, because you see staff quarters you can do in one You can do it in uh, two, uh, two floors or even three floors are also possible. So you can have many quarters. So 15 meters by 10 meters. Number 12 is the cabin of the in-charge engineer. Number 13 is maintenance staff, line staff. Because when there will be fault, they will be going. But when there is no fault, they are sitting there. So you have to keep some arrangement for their sitting. Number 14 is control room. There all 11 kV switch gears are there. Number 15 is battery room. You see, complete control, breaker making on and off or any control is through DC. You cannot depend on AC. No doubt, usually you are converting AC to DC using rectifier. But if AC is lost, that means both the two incomers are lost, then you will lose the control. Control is the heart. You should not lose the control. So you will be feeding controls through 220 kV, 220 volt battery. So that battery room is there. That 15 is battery room. Number 16 is urinal and lavatory, etc. Number 17 can be outdoor also, can be indoor also, and that is capacitor bank for improving power factor. And number 18 is garden. You can have a garden or you can have a storage space, right? So uh, this is all, if you see. So what is the length? 18 meter plus 18 meter, 36 meter plus 10 meter road, 46 meter plus I am going for 10 meter. So 46 plus 10. So 56 plus I am leaving 2 meter on both sides. So uh, that takes me to 60 meter. So 60 meter by 60 meter land I need. That I have decided. You see. So this is known as engineering work. You have to decide how much space you will need. And then wherever you have to have a substation, you have to demand from the people whose land. It may be government land also, but government also will ask for money. So you have to purchase that land, right? So this is known as land acquisition. So you have done the land acquisition. Uh, so after having this, what will be the layout? Now I am doing three-line diagram. That is, I am seeing from the helicopter, from the top. It is plan. This will be the plan. So you see, I have shown three phases. So three incomers I have shown. Third, that is plan. That is also shown. Between two phases, I am leaving 1.5 meter, right? And base you can see. You can see the bus bar, right? This is the bus bar. And this is the sectionalizing breaker on both sides. There are isolator. Then this is PT. And this can pass. ये दोनों touch नहीं करेंगे. These two things will not touch because this line may be some 1 meter or 1.5 meter above. So you are taking to from one half to the second half. So PT is being fed from second half also. Then there are once again three incomers for transformer feeders. That is, transformer is being fed. So circuit breaker is there. In between you can see there are CTs. So this is lightning arrestor, right? Circuit breaker, isolator, CTs for incomers and CTs for transformers, right? And then circuit breaker is then there is transformer. From transformer 11 kV side is income. I mean, it is indoor. So it is run, the uh, pit is dug. I mean, it will be in the pit, right? So in the dug pit, it will be there. And on there, you will have a ice, that the iron, uh, complete thing is uh, made closed by iron, uh, iron cover. So this is the, you can see from transformer, this is in going by cable, 11 kV cable. 11 kV cable is leading to control room. Here all 11 kV switchgears will be there. And then 11 kV outgoing feeders will go out in different areas. And all other things which I had shown, cabin, etc., are shown here. So now this becomes the complete layout of substation. So now you know this much. So this much you have engineered, right? Then the next very important thing is key one line diagram. Single line diagram of a substation. Because that gives the complete. Actually, if you read this, you know everything about substation. So here it is single line diagram. I am coming from incomer 1. Similarly, all incomers. Lightning arrestor, earthing switch, isolator, breaker, isolator. Here I have not written the short specification. It is usual practice to write the short specification also. Then CT. I have shown two cores. CT primary is one, but CT secondary are two cores. One CT core is feeding the meters. That is the, I have shown ammeter, watt meter and whatever meter, and another CT is feeding 67, that is directional relay. Here for incomers I will need directional overcurrent relay. And I have got 67N, that is directional earth fault relay. So this is what I know from this. Then I'm coming to bus. This is the sectionalizing breaker, and this is from another half to PT. PT is only one. It is feeding voltmeter, wattmeter, potential coil, whatever meter, and 67 because the directional relay needs voltage juice. So I'm feeding 67 also on PT. Then for transformer, there are three CT cores. One is for differential protection. Another is for overcurrent and earth fault protection. 51N is earth fault protection. And once again, ammeter, wattmeter, and whatever meter. So that is the arrangement. Then I come to breaker, isolator, transformer, breaker, and then once again on secondary side, ammeter, wattmeter, whatever meter, 51 and 51N, that is overcurrent and earth fault protection, and then 87, that is the differential protection, because it should be on both sides of the transformer, right? Protection we are learning separately, so transformer protection also we are learning. Probably transformer protection we have finished in transformer 3. So then we come to 11 kV bus. So here if you see there are two lines are, I mean these two arrows are shown. That means this breaker is an incomer breaker, indoor breaker. This is not exposed to rain or anything. This is in the building, right? These relays are also in the building. Even these relays, all relays are in the building, but CTs are outdoor. But CTs on this side, 11 kV side, are indoor. 11 kV side, everything is indoor. Then you come to 11 kV bus. You got the uh, arrangement I am using is the single bus arrangement with sectionalizing isolator, and then once again PT I am feeding from two halls, then all outgoing feeders. All outgoing feeders, there will be overcurrent and earth fault relay and the meters. Then I need a capacitor bank to improve the power factor, right? So this much is the complete single line diagram, which will let you know how will your substation be, right? So generally you have known everything, but if one wants to know, one should know what is lightning arrestor, what does it do, what is its function. That if you are learning for the first time, you should learn. Otherwise, if you know everything, our engineering finishes here at this point. But it will go on because we will talk about little theory of lightning arrestor, little theory of circuit breaker, isolator, CT, power transformer. And then we will also learn how to test these things. So uh, that way, it will take about 15 to 20 sessions. This is the third session on this. So with this, we are coming to an end of third session. So this much engineering we have learned. Actually, we have started engineering in this session. First two sessions, we have learned only busbar layout, busbar arrangement. Third session, we have started real engineering. So as I told to you, this is very important. I have not seen any book for this. One book of Satnam and Gupta is there. Satnam is the chief engineer in, was once upon a time. Right now he is living or not, that also I don't know. But the book is written by Satnam Singh. He is a Sardarji, and he was chief engineer in Punjab State Electricity Board, and Gupta is the teacher. He is professor in some Punjab college. So it is a very good book, very good combination of industrial person and a academician. So book is highly important. If you want, the book is available in market. You can order through Amazon or through, you can go to any shop and ask for that book. If that book is not available, if you give them full name, the full name of book is Substation Engineering and Practices by Satnam and Gupta. Mostly Dhanpatra and Sons is the publisher. You can ask, he will order for that, he will get it for you and he will give it to you. That book is a good book for substation engineering. But the unfortunate part is that the book is so old that the units are in foot and inch, etc. It is not in or meter. So that disadvantage is there. Otherwise, theoretically, that book is good. That one book I have seen, but that one book also does not explain all that I am explaining. So this is very important. This is going to give you a very good insight through the substation engineering. And the person who knows engineering, there are hardly 5% know engineering of a substation or power station. So engineering work is very good. It will pay you good pay. You will be getting promotions fast, right? So for that, please stay tuned with Head Up Me. Let the name of Head Up Me rise in the sky. Let all electrical engineers know that. And once you know that, you will open that in YouTube. And in YouTube, you will go on seeing one after another video on engineering side. I'm going to write the videos. I'm going to give the videos on power station, thermal power station, this project engineering, and third power system protection. Totally about 200 videos and 150 to 200 videos I'm planning. It will take about 1 year. Right now, some 55 videos I have already given. Each video is hardly of half an hour or at the most 45 minutes. So you can easily read through. And if you read, then only I earn view hours. So I am giving this free of cost. So what you have to pay me is viewer. And if you pay me viewer, YouTube is paying us. But they start paying after 4,000 viewers. And as on date, it is only 1,000 viewers. So I would request you to read, to hear complete video, and to share to as many electrical engineers as you know, as many people who are interested in this area. So I would request you to become my ambassador, my marketing engineer, and do it for me because you are getting this free of cost. Till then, my friend, I thank you all for sparing time to hear me, and good day.